Hello everybody, this is Professor Miano giving you a Math 50 pre-statistics lecture on section 7.3 and 9.1. So we're going to be hopping around as far as sections are concerned. It's going to be dealing with linear equations and being able to graph them in a very particular context. So we're going to be calling them linear models in 7.3. And then in 9.1, we get a little deeper into working with points and slopes, or points, as you can see, to find the equations of lines. Okay, let's get right into this couple of applications that we'll dive into that reflect a linear model. So if we want to construct a linear model of the form y equals mx plus b, there's a few things that we'll be doing. The first thing that we'll be doing, and let me go ahead and get my drawer in play here, is to figure out who is the explanatory and response variables. Being able to identify those is very important because they're not going to be given to you as x and y respectively. It's going to be your job to see what information comes first in the scenario and then what other information is based off of that or is a direct reflection of that first piece of information. So that'll be going on with that. We're going to use this to outline two different scenarios that are described in order to calculate the slope. Then pairing that with one of the ordered pairs, one of the points that are given, we're going to find the equation of the line. And then we're going to graph it. We're going to do this 2 times over. We have 2 examples that we want to entertain this process with, and it as follows. Here's number 1 anyway. In 2010, a college's enrollment was 20,000 students. Each year, the enrollment increases by 2,000 students for the period of 2010 to 2015. Let E be the enrollment in thousands of students at T years since 2010. So let me let you in on a little secret, guys. Pretty much every single time you see T years as one of the possible variables, that is almost always the explanatory variable. It acts like the x in an xy pair or x in a linear equations y equals mx plus b. So T is akin to x, okay? So the explanatory variable, that's going to be your T. And the response variable is going to be your E in the enrollment in thousands of students, okay? Because based on the year, we can determine what the enrollment was. Like as far as like the cause and effect going on with this data set, it's years is the thing that explains the response of the enrollment. Okay, now let's go ahead and entertain these let's come up with the slope of the linear model. So sometimes it'll come in the form of 2 ordered pairs, but this year, or this one, we are going to take the information a little bit differently. Certainly we have an initial condition, which is what I would say is going on with this 2010. Ooh, let's have this color actually. 20,000 students. So we can use that to get an ordered pair in order to calculate the slope and again, T is going to be years since 2010, so that'll be 0 years since 2010. We had 20,000 students. So we can use the ordered pairs 0, 20 to represent that. So this is in 2010, there were 20,000 students. Okay, so that's like how you would interpret what's going on with this ordered pair. And then it says each year the enrollment increases by 2,000 students, and it's over the span of these 5 years. Okay, an increase of 2,000 students means that the slope M is going to be a 2, a positive 2. And remember that the number of students is in the thousands, so this is actually representing a rate of change increasing of 2,000. Okay, so if this is the slope and this is your initial condition, this gives you your b value in your y equals mx plus b. Now remember, we're not talking about x and y here, we're talking about e and t as far as the variables are concerned. So the slope equals 2, that accounts for part b right there, okay? And so we're ready to come up with the equation of the linear model. Sorry, I still want to draw, but I want a new color. Let's take this dark blue. Okay, so for C, we're going to go E. That's very much like your Y in the quintessential point slope or slope intercept formula. Y equals mx plus b. We have E equals 2t plus 20. And t ranges from 0 to 5. So we can just account for that, I think, pretty well by having this compound inequality off to the side. Okay, cool, cool, cool. Now let's go ahead and graph this model. Let me go ahead and go with black. And since we're talking about enrollment and years of 2 variables that are strictly positive, I'm going to go ahead and draw my axes on the leftmost edge, so you can see my cursor going for it here. And I actually have a soft straight edge that I'm using to make this line really straight. And then, so that'll be my E axis. So this will be enrollment in thousands. Okay, and my horizontal axis will look like this. Okay, so there's my T axis, and this will be years since 2010. Okay, so I want to have what tick marks, you know, every 2 I think would be sufficient here. There's 2005, sure. And then if we want to have 20 be the initial condition, and it's supposed to go up, maybe this is 10. Or wait, if it's only going up by 2, maybe I'll do a little different. Maybe I'll go up by 5s. 5, 10, 15, 20. Yeah, that'd be good actually. So every 2 tick marks, I'm going to go up by 5. Okay. Oh, I do not like those. Those are so sloppy. Let's try that again. Even that one's a little not great. And this one, let's just start over with the tick marks here. Try that again. Better. Okay. Fine. Sure. Okay. So that'll be 5, 10, 15, 20, 25. Okay. So, but we're starting off at 20. Okay, anyway, that's fine. So we're going to plot, by graphing the model, we can plot the initial condition, so that's probably a good idea. And what color do I want to use? How about this pink color? That's fine. So at 0, oh, you know what? But I haven't labeled the years yet. So years since 2000, come on now. 10, maybe this will be 1, 2, 3, 4. Oops. 4 comes next. Y'all, 4 comes after 3, not 5. LOL. Okay, 4 and then 5. Great. So let's go back to that pink color. Cute. Okay, so we're at 20 as the initial condition. Maybe I'll go up to 5 and I'll use my formula in order to determine how what the enrollment is at year 5 after 2010, aka 2015. So if I plug in for part D, this is the some part of part D is really the graph here, but yeah, get rid of that. So yeah, what is the enrollment in 2015? It looks like it'll be 30, right? Which is like all the way up here. Cool, so that'll be 10 plus 20, which is 30. Cool, cool, cool. So at 5, I should be all the way up here with it. And so I could just draw a line that connects these two. So you can't see it, but I am lining up a straight edge, and I'm going to try and just draw a relatively straight line from there to there. Okay, it's a little bit wobbly. That's what you get for trying to use a stylus on a screen and not having the, you know, shape editor like you do in like Word or something like that. Cool. Okay, sorry. I'm a little bit tired. In fact, this could keep going, but because of the restrictive period that was mentioned here, probably best to keep intact the context by saying we're not going to, what's the word I'm looking for, graph anything beyond that. So we're just going to limit ourselves to years 0 through 5. Okay, so that's that one. Let's go ahead and try this process one more time with this student savings account problem. Okay, so a student savings account has a balance of $4,700 on September 1st. Each month for 6 months, the balance declines by $650. Okay, so this means we're taking out $650 every month, so the slope is going to be negative. The slope is going to be essentially this negative $650 because that is the rate of change. That is the change that is occurring at every time step. And the time step here is in months. You'll want to note that right there. Okay. And again, we have time involved in our problem and a resulting balance. So that means the explanatory variable, yes, is time, t, and the response variable is going to be the b balance. Okay, find the slope of the linear model. Okay, so that's going to be this $650, but remember it is negative. Actually, you know what, let me go ahead and I want to change the color because it's just fun to do that, and we have the option. So let's do this teal color. So the slope is going to be negative 650. Why? Because that's the amount that gets deducted every time step, which in this case is in months. And what does it mean in this situation? It means the slope of negative $650 or negative 650 represents the decrease in the balance over every time step. Which I'll parenthetically put month. Cool. Great, let's find an equation for the model. Now we're given the slope, negative 650, but we're also given an initial condition, just in case we're not clear on that, and that is that the savings account, the initial balance in the scenario, which is happening at September 1st, was $4,700, okay? So that means that we can get going on this equation saying it's in the form of y equals mx plus b. Instead of x and y, though, we have t and b. Furthermore, m is negative 650 and b is 4,700. Okay, so let's put all that information together and say b equals negative 650 t plus 4,700. Okay, and we're going to use this to graph the model. I'm going to do the same initial things that I did for the last one, which is to draw the axes in the same place on the grid on the outer edges, and then I'll label the axes and put appropriate tick marks in. So here is my first line put in, and that's the B axis, which is the balance, account balance, we could say. And then across the bottom axis, the horizontal axis is definitely time. Okay. So that'll be months since September 1st. Now we don't have any kind of end to it. It's not like, oh no, we did. It says 6 months, so there should be 6 tick marks here. So here's 0 months right here at the intersection of the two axes. Here's 1 month, 2, 3, 4, 5, 6. So we want to make sure that there's a tick mark for each of those. And okay, so $4,700, and we are decreasing by 650. So let's see, 1, 2, 3, 4, 5. We could have these by $1,000 for every 2 tick marks, I think would be appropriate. So this will be 1,000, 2,000, 3,000, 4,000, 5,000. And we'll have it in dollars, so maybe I'll put that parenthetically after account balance. All right, so we can plot our initial condition of the $4,700 on the vertical axis. And let's do it in this lavender color. That's real pretty. Okay, so 4,700, that's going to be, about halfway between the halfway mark. Between 4,000 and 5,000, halfway between the halfway-ish. A little bit below, in fact. And then if we wanted to calculate, what it's looking like at 6 months past, we could plug in a 6 for t and calculate the b value. So what's negative 650 times 6 plus 4,700? So, take out your calculator. Don't bother doing this by hand. 4,700. I believe that'll have a balance of $800. Okay, so that'll be $800. Okay, so for month 6, we're down to $800, which is going to be right about there-ish. Okay, and literally you just need 2 points plotted in order to draw a line. So going from the absolute highest that it could be, the original balance, all the way down to the last month in the scenario. That covers everything possible. But I could have done, in order to pair a little bit closer, I could have done 2 months or 1 month, but I just feel like this gives me the best ease of drawing the line. So pretend that this lavender bit right there is perfectly straight. It's a little bit wiggly, trying to use, even though I'm trying to use a straight edge, it's not coming out so great on this, what do you call it, tablet surface with the stylus. And that's that. Here I've graphed the model, I have everything labeled, and it's good to go. And that's all that I have to present on 7.3. We're just graphing models, and there it is. So moving on to section 9.1, we are going to get into the slope-intercept form of the equation of a line. Let me go ahead and get my drawer going on there. So that'll be y equals mx plus b. We know this one. And why is it called that? Because here's the slope, m, and here's the y-intercept, b. It has those elements. So I'll go ahead and define those. M is the slope, b is the y-intercept. Just to be clear, b is the y value of the y-intercept, which is technically an ordered pair. 0b, it's a point. Okay, great. So let's go ahead and use this stuff and practice figuring out the equation of the lines that meet certain criteria. Like for number 1, for instance, we're given a slope and an ordered pair. So we actually need the point slope formula, or that's one way that we could tackle this. So point slope formula, let me slope formula looks like this. Y minus y1 equals m times the quantity x minus x1. So this might look familiar to folks. This is perfect for just plugging this information in and going straight to the equation of the line. And we're going to put it in slope-intercept form, the y equals mx plus b when we're all done. Okay, so go ahead and for this particular one, plug in, this is your x1, y1, and plug it in. So that'll be y minus, what's y1? It's -6, equals m, which is -5, times the quantity x minus x1, which is a 1. Cool. So we just need to do some algebraic manipulation in order to get it into that slope-intercept form, which is basically solve for y. So one thing that I see right away that can be done is changing the sign right here, and I'll also distribute this -5 here and here. I'll do that all in one step. Okay, so that'll give me y plus 6 equals -5x plus 5, right? There's a little sign change there. And then I will subtract 6 from both sides, which will give me y equals -5x minus 1. That'll be, again, subtracting 6 here gets rid of the 6, subtracting 6 here gives me a constant term of -1. So there you have it. Okay, all done for that one. Cute. Okay, now for the rest of the examples, we may or may not be using the same method in order to move forward. You got to really look at what you're given, and that'll determine the most effective process in order to get your equation of your line and also to eventually get it in slope-intercept form. Notice for number 2, we are given the slope, cool, and we're given an ordered pair, which happens to be the y-intercept. That means you are looking at literally the value of b straight in the face. It's -2. So instead of y equals mx plus b, it's going to be y equals mx, minus 2 or plus -2, but go ahead and call it subtraction, which it really is. So we can go straight to the equation of the line here. Y equals -5/3 x minus 2. Again, technically, you're plugging in a -2 for b, which will read as y equals -5/3 x plus -2, but I'm, shortening the process by a step and recognizing that when you add a negative number, it's the same as subtracting it. So hopefully that little piece of algebra lands, but if you want some more explanation to that, I'm happy to give you some more info to fill in the details. Now here we're given 2 ordered pairs, so we can't use the same process that we used for the first 2 examples. We have to first calculate the slope, and if you recall, here is the slope formula. And so we have to decide who is x1, y1. Let's say I decided that this one's x1, y1, and this one's x2, y2. Here, sorry, I meant to oops, circle that whole thing. Let me try that again. There we go. So and now it's just a matter of plug and chug. Okay, so y2 was -2 and y1 is -3, so we have to subtract it. Hold on. Oi, come on, eraser. There we go. Subtract -3. And so that's y2 minus y1. x2 is 6 minus x1, which is a 2. So that'll be, okay, don't forget to change the sign here. Boom, boom, right? That's going to be addition. And then what do we get? Well, we get a 1 in the numerator because that's -2 plus 3, and then we get a 4 in the denominator. Okay, so the slope is 1/4. Cool. Now choose one of your ordered pairs. Maybe choose the first one, x1, y1, because the numbers are slightly smaller, and use that point slope formula. So that'll be y minus y1, which is -3, equals the slope, which we just calculated as 1/4. Times x minus x1, which is 2. Okay, so it's going to be a little bit funky because we're going to distribute through this 1/4, and that's going to do what? I'm going to do it in orange actually this time. It's going to leave a constant term that's a fraction. We're going to also change the signage there because we're subtracting by a negative. And then we get y plus 3 equals 1/4 x minus, now what's 2 times 1/4? Well, that'll be 2/4, which reduces to 1/2, okay? We're going to subtract 3 from both sides, and that'll leave us with y equals 1/4 x minus 3.5. Or you can call it 7/2, right? Or 7.5 or 3.5. I don't know. It's probably best to leave it at least in a fraction form, like as a mixed number or as an improper fraction. Maybe don't mix decimals and fractions. It just doesn't like look very good aesthetically. Okay, but that'll do for that one. Okay. If we want some more discussion on the algebraic details, just let me know in class. I'm happy to demonstrate that further. Okay, let's do another one of this type where we have some ordered pairs. Again, the first step is to calculate the slope, and first you have to decide who's x1, y1. We'll just go ahead and stick with convention and have the first one that I see be x1, y1, and the next one that I see be x2, y2. You could technically switch it and have that be fine. So therefore, m equals -3 minus -1. And then in the denominator, it'll be x2, which is -2 minus 6. Okay, and that will yield, well, boop, boop, if that's helpful. Some people like to do, when you deal with subtraction, they call it addition of the opposite or adding a negative. And I think that's kind of helpful here so that I can see that I have a grand total of -8 in the denominator. And in the numerator, it looks like it'll be -2. Oh, again, this slope will be 1/4. Cute. Okay. And so that's all well and good. I could still use my x1, y1, or I could use x2, y2, whatever, in the point slope formula, which is next. So I'll go ahead and I'll stick with x1, y1. So that'll be y minus a -1 equals m, which is 1/4, times x minus x1. X minus x1 is a 6. Again, we're going to have fraction stuff going on, but it's nothing we can't handle. Okay, so yeah, distribute this through, change the signage there, and what's next? We have y plus 1 equals 1/4, excuse me, x minus, what's 6/4 going to reduce down to? 3/2? Sure. And then I'm going to subtract 1 from both sides in the form of a 2/2, so that'll be 5/2 actually. Subtracting 2/2 or 2/2 from a -3/2, it'll be -5/2 total. So therefore, it'll be y equals 1/4 x minus 5/2. Cute, so fun. Okay, here are some more that are totally different than what we were doing before. Really here we have a slope that's 0, and we go through the point -3, 8. So you're supposed to remember that lines with 0 slope are horizontal lines. So I'll say it's horizontal with an exclamation point. And horizontal lines always have the form y equals some number. What number? Whatever the y value is of the point it's supposed to go through. So therefore y equals 8 is your equation, and it's literally that quick and easy, so long as you know the trick. All right. Similarly, what's going on with number 6? Well, we have that m is undefined. I did not mean to make that mark right there. Let me erase that. M is undefined means that we have a vertical line. All lines that have undefined slopes are vertical, and they come in the form of x equals some number. What number? The x value of the ordered pair, so -4. Bing, bang, boom, you're done with that one. Okay. Next. Ooh, we've got some decimals. We need to round to 2 decimal places. Okay, that's great. So our slope is given, then we're given a point in addition to that. So point slope formula is where it's at. Here's y equals y1, which is y minus y1. Oh my goodness, getting ahead of myself. Where's the eraser? Get rid of that. Okay, so that'll be y minus y1, which is 3.8, equals the slope of 1.3 times the quantity x minus 6.6. Okay, so you're going to reach for your calculator for this distribution step, okay, which is this and this. Well, at least this step, you'll reach for a calculator. So that'll be y minus 3.8 equals 1.3x, and then what's 1.3 times 6.6? 1.3 times 6.6 equals 8.58. So, and it's minus 8.58. 2 decimal places at once. Okay, cool. So let's go ahead and add 3.8 to both sides. And we will get -4.78. Y equals 1.3x minus 4.78. Cute. And that is that for that particular exercise. All right, let's see what's next. All right, let's interpret a point. Now a point is going to be, it's an ordered pair, right? So we could put that ordered pair, which often comes in the form of x, y, but could be use different letters. Okay, and furthermore, x, or whatever the initial item, is always the dependent variable, or the explanatory. So x is explanatory and dependent, while y, or whatever the variable is in the second position, is the response, x is the independent. My bad, guys. Explanatory or independent, the y is the response, and it's dependent. I am so sorry for the confusion there. I misspoke. X is definitely categorized as the independent variable, while the y, or the second variable in the ordered pair, is always categorized as the dependent. It depends on what was given for x. It's like the cause and effect stuff with the explanatory and the response variable. The explanatory variable comes first, and then the response variable comes later, and it is its value is completely dependent on what came first in the explanatory. Okay, so let's answer each question. The cost of riding a taxi m miles is given by C for cost, equals 2.25 miles per plus 2.60, where C is the total cost. they're asking, what is the slope of the linear model? That's going to be this value right here, m equals 2.25, because it's the, oh, and it's confusing, extra confusing, because m is the independent variable. It's acting like the x in this model, but m is also the quintessential variable is attributed to slope. So maybe I will make a point of not saying that it's m. I will call it the slope. We'll categorize it that way. Interpret the slope into a sentence. So it's cab fare, right? Riding a taxi. This is saying that every mile that is driven warrants a charge of $2.25. $2.25 for every mile. It's basically one way to interpret that. Okay, so for this next one, we want to interpret the point for 11.6. Okay, so this is saying that 4 miles were driven. So in this scenario, that's supposed to be a comma, but that's out of control. Let me try that again. In the scenario, 4 miles were driven. And the charge for the taxi ride was $11.60. All right, cool. Boop. Moving on to the next thing. The distance in miles driven by car after t hours is given by d equals 65t plus 10, where d is the distance traveled. Oh, you know what? I remember that this ordered pair was not appropriate for this problem, so this is a little bit of a typo. Let me, in real time, address that. I might have to pause the video real quick and figure out what an appropriate ordered pair was. This is my vague recollection from the last time I gave this lecture, and I forgot to fix that, so I'll try and remember to do that in the future. In any event, we could still salvage this problem right here. It says the distance in miles driven by a car after t hours is given by d for distance, equals 65t plus 10, where d is the distance traveled. So the slope of the linear model here is 65. Slope is 65. Interpret the slope into a sentence. So this is the 65 is going to be in miles per hour. That's going to be the speed of the car, basically. So the distance is always rate times time. There's this relationship, and then there's an extra 10 that's tacked on there, right? Because let's say that there's an extra 10 tacked on there. Why would there be an extra 10? Distance in miles. Oh, because you started off 10 miles away from a certain area. Not really sure, actually. But if I was going to just interpret the slope, it would be for every unit of time, I've gone 65 miles, and the unit of time is hours. So it's basically 65 represents the speed of the car. Uh, 65 miles per hour. I'll put MPH for short. Okay, so this ordered pair does not work. What if we had a 4 in there? So hold on. Plus 10. So keep the 4, but the ordered pair that really should be in here is 270. Okay, so this is the ordered pair that actually makes sense to us. Okay, so if we're interpreting this point, 4, 270, we would say after 4 hours, the distance traveled is 270 miles. Okay, cool. And that is it for today. Great. So let me know if you have any questions about this when we meet in class. See you then.